Good morning, students. Welcome to class on Tuesday the 26th. Welcome to your favorite class, and that's geometry in case you're confused. And let's see if we can't get started with some quick announcements here. Hope you guys are doing well. And yesterday we had to get a little negative comments out of the way and get things going, so that's water under the bridge. Hope you guys have had a chance to work on some makeup work last night and in class yesterday. And keep that going throughout the week. Okay, here we go. There'll be a quiz this Friday. There'll be no notes this Friday, just a quiz. It will be a big quiz. Everybody should have 5 bonus points in their account. If you don't, shoot me off an email and I'll try to give you some more bonus problems this week. Okay, there will be a test next week. I'm not sure what day yet. I will try to come in for that test. You owe me nothing unless you have incompletes to turn in, but we did not have homework yesterday, so there's nothing to turn in today unless you have incompletes. I'll announce this every day. Ashley, no need to be embarrassed. Last week I announced every day to Tara that she had a test to take, so I try to announce things every day so you don't forget. I'm trying to be a help to you. If you, Ashley, Tara, Megan, Kate, if any of you are still behind on homework from 7.1, 7.2, or 7.3, please make that up as soon as possible, like yesterday. But that's not due by this Friday. I will accept that next week if I have to, but you know it hurts you to get behind. Now all the other assignments, Ashley, that you owe me, those are due by this Friday. Gotta have those by this Friday or they will become zeros, and that's basically it. So let's have a great class period. I'm going to try to go fast today and give you a lot of time to work on your homework, and maybe you can get it done in class. Okay, so let's roll. Please grab your notebooks, and anytime throughout this video you need to pause the video, please do that. Don't hesitate to do that. Okay, all right, we are looking at this. Copy this in your notes please while I'm talking. We're going to get into 2 other ways today to prove that triangles are similar. Okay, and these 2 ways that we're going to learn today are called the side theorem and the side angle side. Now those should look familiar because we've had some theorems and postulates like that, but these have a little extra word thrown in there. You do not need to write this down, so please don't. You'll see this later, but they're called the side similarity theorem and the side angle side similarity theorem. So that's what we're going to look at today. 2 other ways to prove that triangles are congruent. All right, now remember, you don't need to write this down, just listen. Okay, remember, we already learned 1 way to prove that triangles are similar. We learned this last week. I hope you remember. It was called the angle-angle postulate. The angle-angle postulate. And it said something like this. Let me quickly, and again, you can copy this down. I'd encourage not to really worry about it. It's not a big deal. We've done this before. I'm just trying to refresh your memory. What we said, that's a nice triangle, isn't it? What we said is this. We said if I have, we'll call this 60 degrees. We'll call this 60 degrees. We're going to call this 90, and we'll call this 90. Now, what we said is if one angle in a triangle is congruent to another angle, and another angle in this triangle is congruent to an angle over here, then these 2 triangles are, without any doubt, beyond the shadow of a doubt, 100% for sure, these 2 triangles are similar. Okay, that's what we learned last week. If you don't remember that, remember it now, please. I mean, this is very important. That's 1 way to prove that 2 triangles are not congruent, but similar. If 2 angles in one triangle are congruent to 2 angles in another. Now, could these 2 triangles be congruent? They could be, but we don't know for sure. What we know for sure is they are similar. They are similar. So we're going to learn 2 other ways today. Okay? All right, here we go. Let's jump into it. I'd like you to copy down this first theorem, please. This is called the side similarity theorem, SSS, And here's what it states. Please copy this down while I'm reading it. And if I go too fast, just pause the video. If the corresponding sides of two triangles are proportional, and we'll talk about that word there in just a second, then the triangles are similar. Let me read that again. Like reading it twice really helps. It probably doesn't. I'm going to give you a picture of this in a second. If the corresponding sides of two triangles are proportional, then the triangles are similar. Let me give you an example, and I would like you to copy this in your notes, please. Would you do that? Please copy this in your notes. Okay, we're going to draw a right triangle there, and then a smaller right triangle here. All right? Now, let's call this triangle ABC. Let's call this triangle DEF. Now what I'm doing is I'm giving you an example. I'm giving you an example of what this theorem is teaching you, so please watch carefully. Okay, we're going to call this, no, I don't want to worry about that. We're going to call this a length of 8. We're going to call this a length of 6. We're going to call this a length of 10. We're going to come over and call this 3, this 4, and this 5. Now, we're going to run a test. Well, Mr. Earhart, what's the test? It's the side, side, side test. I'm going to see if all of the sides are what? Proportional. And if all of the sides are proportional to each other, then the triangles are similar. Now, let's see what this means by proportional. See this AB? I'm going to say that 8 goes with 4. So 8 over 4. Okay? Equals 10 over, well, we're going to say 10 corresponds with 5. 10 over 5 equals, and then we're going to say 6 goes with 3, so 6 over 3. There. Do you see how I did that? Now, if I reduce all of these fractions and I get out equal numbers, then all of the sides are what? Proportional. So let's reduce 8 over 4. I get a 2. Let's reduce 10 over 5. I get a 2. And let's reduce 6 over 3. I get a 2. Bingo. We are good. 2 equals 2 equals 2. So all these fractions were equal. So all three of these sides here are what? They are proportional to these three sides over here. So because of that, I can now state that these two triangles are what? Similar. Okay? Hopefully you see that okay. Now if I asked you to write a similarity statement, you would simply say triangle A, B, C is similar to triangle, make sure you match up corresponding angles with corresponding angles, triangle D, E, F. And there we go. Okay? So if these three sides are proportional to these three sides, we can state the triangles are similar. Now I'm going to go on to the next theorem, and then we're going to work on 1, 2, 3, 4, 5, 6 problems. So the class period is not going to be very long today. I'm going to give you 6 examples, and then we're going to be done. I'll let you work on your homework. Okay, please copy this into your notes. This is the other theorem. Obviously, you're responsible for all these theorems when it comes to your quiz this Friday and your test coming up. Okay, the side angle side similarity theorem, SAS, here's what it says. And I'll give you an example in a second and help you understand this. If one angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides that include these angles are proportional, then the triangles are similar. Okay? Now again, anytime that I go too fast, just pause the video. Let me give you a picture of exactly what this is saying. So please don't stress out, just watch and learn, okay? Alright, there's one triangle, and I'll draw a bigger one. Alright, now copy this in your notes, please. This is very important that you have notes here that you can look back on, okay? Now, I'm going to put an angle measurement here, and I'm going to call this 45 degrees. Okay? And I'm going to come over here and call this 45 degrees. Now, I'm going to say this side right here is going to have a length of, I don't know, we'll say 6. And we'll say this side over here has a length of 9. And we'll say this side right here has a length of 4. And this side right here has a length of 6. Now, students, would you please watch carefully. I have to have, first of all, to use this theorem, an angle that's congruent to an angle. And I obviously have that, don't I? Does everybody see that? 45 degrees and 45 degrees. But here's where students become confused. They think that then if they have any two sides over here proportional to any two sides over here, then we're good. And that's not what it says. It says the lengths of the sides that include these angles. Now what that means is this. It has to be the two sides that make up that angle. And these are the two sides that make up 45 degrees. This side right here and this side right here are the two sides that make up that 45 degree angle. So if I have this side over here, some number over here, I don't even care about it. I can't use that. Not when I'm using side angle side similarity. It has to be a side, then an angle, then a side then an angle, then a side. And what do I have to have? Well, first of all, I have to have congruent angles, and I have that. And then I have to have sides that are what? Proportional. Let's see if I have proportional sides. 6 corresponds with 9, so I would say 6 over 9 equals 4 corresponds with 6, so 4 over 6. If you reduce both of those fractions, you would get 2/3 equals 2/3. Bingo, look at that. So I have a side angle side relationship with a side angle side in such a way that the angle is congruent to the angle and the sides, 6 over 9, 4 over 6, are proportional. Okay, and that's what that theorem means. All right, so with that in mind, let's quickly do 6 problems. I'm going to turn you loose on your homework. Here we go. Let's get started. Please copy this in your notes. Copy that in your notes, please. Triangle PQR, triangle STU, label the sides, 8, 10, 12, label the sides, 4, 5, 6. We'll call this triangle A and triangle B if we need to. I'm not even sure why I put that in there. I'm going to go ahead and just cross that off. That really doesn't even need to be there, so forget that. Okay, here's my question. Can we state that these two triangles are similar? Well, here's our 3 methods. Are you ready? Angle, angle, or side, 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 or side, angle, side. Okay? Now, do we have any angles in this triangle or this triangle that we know? No, we don't. So we know we can't use this one, and we know we can't use this one because we have no angles that we know. But we might be able to use side, side, side. So I'm going to say 8 corresponds with 4, 8 over 4. 12 corresponds with 6. And 10 corresponds with 5. Now, if all 3 sides are proportional here to all 3 sides over here, then I have similar triangles. Well, reduce this, you get a 2. Reduce this, you get a 2. And reduce this, and you get a 2. Good. Yes, you can state these 2 triangles are similar. So let's go ahead and write this. Go ahead and write this down. I'm going to say triangle PQR is similar to triangle STU by what method? Side, side, side similarity. Side, side, side similarity. Do you see it okay? All right, let's try another one. And by the way, some of these are not going to be similar, so you have to write no for some of these. All right, number 6. Where did I get number 6 from? Wow. Whoo, it is late at night. It is 11:30 at night. All right, number 2. Please copy this in your notes. Triangle ABC, triangle DEF, sides 6 and 3, 10 and 5, angle 61 degrees, 61 degrees. Please copy this in your notes. Now, I want you to tell me if these 2 triangles are similar. Yes or no? Well, the only 3 methods we've learned are angle, angle, side, and side, side, side. Now, we can't use side, side, side. We'd have to know all 3 sides and all 3 sides, so forget that. And I really don't see us using angle, angle because you'd need 2 angles here and 2 angles over here. We only have 1 angle. The only option left is side, angle, side. And notice I do have a side, then an angle, and a side. and then a side, then an angle and a side. Now that doesn't mean they're similar. We got to run our test. First of all, in order to use side, angle, side, I have to have a congruent angle. Do I have a congruent angle? Yes, I do. Now the sides have to be proportional. So 6 would go over 10 and 3 would go over 5. Well, let's reduce both fractions and see if we get out an equivalent statement. Yes, we do. 3/5 equals 3/5. So, yes, I can state that triangle ABC is similar to triangle, now be careful here, ABC, similar to triangle, it would be D, then E, then F. By what reason? By side, angle, side, similarity. All right, moving on to problem number 3. Problem number 3. All right, please copy this in your notes. We have triangle JKL and triangle RST, sides 12, 13, and 5, 12, 15, and 9. And we're going to see if these two triangles are similar. Now, if I go too fast, just pause the video. I'm asking you, are these two triangles similar? Well, we've learned 3 ways to use angle, 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 side, or angle, angle, side, 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 and then side, angle, side. Excuse me. So, I'm not going to use angle, angle, or side, angle, side because I have no known angles in either one of these triangles. The only thing I have is side, side, side. So let's see. Side 12 would correspond with side 12. 13 would correspond with 15. And 5 would correspond with 9. Now, unless I'm missing something here, there's no way these 3 fractions equal something. First of all, 12 over 12 is 1. I mean, they do not equal. So, no, they are not similar. No. All right, let's try the next one here. Problem number 4, I believe. All right, I want to know if this top little triangle is similar to the big triangle. All right, so is the top triangle similar to the big triangle? Well, copy this in your notes, please. Copy this in your notes while I'm talking. After you've copied your notes, I would recommend that you do a splitting of the 2 triangles. I would draw a little triangle and then a big, wow, and then a big triangle. All right, let's see, this would be WVX, and this would be YVZ. Okay? Now, oh, please don't miss this, students. Watch this so carefully. Please watch this. WV is 4, VX is 5. Do you notice how this, I'm going to do it in red to catch your attention. You notice how this angle here has to be congruent to this angle here. They're sharing the same angle. But now you know what a lot of students like to do, and this is so sad. They want to put an 8 right here for YV. Maybe some of you did that already. I hope you didn't. Look, the whole length of Y all the way up to V is 12. From here to here is 8, and from here to here is 4. So when you split these 2 triangles up, you better put a 12 right here, and over here you better put a 15. Okay? All right, here we go. So, I mean, I want to know if these 2 triangles are similar. Well, the only methods we have are angle, angle, side, and side, side, side. Well, I'm not using side, side, side because I don't know all 3 sides. I'm not using angle, angle because I don't have 2 known angles. But I do have a side, angle, side, and a side, angle, side. First of all, are my 2 angles congruent? Yes, they are. Okay, let's check the proportionality of the sides. 4 goes with 12, so 4 over 12 equals 5 over 15. Now reduce. 4 over 12 is 1/3. 5 over 15 is 1/3. 1/3 equals 1/3. Booyah. Yes, we simply say that triangle WVX is similar to triangle YVZ by what reason? Side, angle, side, similarity. All right, let's go on to the next one. All right, here we go. I want to know if these two triangles are similar. Now, we're going to do what we did before. We're going to split the two triangles up. So, and I won't do this the best, but I'll do it well enough. I'm not going to be that picky. All right, there's that triangle. Then the other triangle comes down, comes up. It's not what I wanted to do. And then over. All right, good. Now, let's go ahead and label this triangle here. H, G, J. Am I going too fast? I'm sorry. I'll pause for a second. Copy this right here in your notes. You want to copy that in your notes. I apologize. Going a little too fast there. And then we're going to split the two triangles up. So here's HJ, HGJ, and then GJ. Okay. And let's see. HG has a length of 10. We get that from right there. And then we have a right angle right here, so put a right angle here. And this is 24, so put a 24 right here. Then we come down here and put a right angle. And we're going to say this is 24, and this is 32. Now, let's see if these two triangles are similar. I'm not going to use angle, angle, because I don't have two angles in one triangle congruent to two angles over here. I'm not going to use side, 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 because I don't have three sides and three sides. What I do have is side, angle, side. I have a side, then an angle, and then a side to deal with. And over here I have a side, then an angle, and then a side to deal with. So let's see if we can figure this out. First of all, these two triangles might be similar, they might not be. First of all, do I have an angle congruent to an angle? Yes, you do. Okay, next we check, are the sides proportional? Now a lot of students are like, wow, what do I do? Do I put the 10 with the 24, the 10 with the 32? Now be careful, think about this. Does it not make sense you want the smaller out of the two sides going with the smaller? Sure it does, of course, if the two triangles are similar. So I would put what's smaller, 10 or 24? Well, 10 is. What's smaller over here? Well, 24 is. So I'm going to say 10 over 24 equals 24 over 32. Now, if you reduce those two fractions, you will get 5/12 equals drawing a blank, sorry, before we go into these, 3/4. 3/4, is that right? I think that's right. Okay, so are these two sides, these two sets of sides, proportional? No, they are not. Not at all. So no, these two triangles are not similar. All right, let's try one more. Let's try this last one. Now, ABC is our model triangle. Okay, I'm sorry, I'm going to pause. Please copy this in your notes. Please copy triangle ABC, triangle DEF, and triangle GHJ. Sides 6, 9, 12, sides 4, 6, 8, and sides 6, 10, 14. Okay, here we go. All right, watch this carefully. Here's my question. I want to know, now please watch carefully. I want to know, is this triangle similar to ABC? And is this triangle similar to ABC? Okay, so let's take it one step at a time. Let's start with comparing this triangle here to this triangle here. Obviously I'm going to use side, 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 so I'm going to find the smallest side out of 4, 6, and 8. That's 4. And I'm going to put it over the smallest side over here, which is 6. The next size is 6. That would go with the next size over here, which is 9, so 6 over 9. And then my largest size is 8, and my largest side over here is 12. Well, let's reduce. I would get 2/3 equals 2/3 equals, look at that, 2/3. So yes, these two triangles right here are similar. Yes, very good. Now, let's go ahead and switch colors of ink, and let's compare this triangle right here with this triangle over here, and let's see if they're also similar. Maybe they are. Okay, well obviously we're going to use side, side, side because I have 3 sides here and 3 sides here, so my smallest side is 6 over my smallest side over here, which is 6. So right away we can see this is going to fail. My next size is 10, and my middle size over here is 9, 10 over 9. Right away we can see they're not going to equal each other. I don't care what fraction you get over here, these already don't equal. So these two are, sorry about that, these two right here, this triangle here and this triangle here, they are not similar. Okay, hope this has made sense. Please copy that homework assignment down for your pleasure and enjoyment. 21 problems. This is the video you can watch at home if you want to, or they're at school today if it helps you. I don't care, with your questions. Okay, so copy this down, page 382, numbers 5 through 13, 15 through 26. Have a great day. Hope you guys are doing well, and we will see you or talk to you tomorrow.